Hi everyone. So today I want to talk about the conversion of amine to amide through a process called the amidation, also known as the condensation, to form amide. And we need carboxylate as our reagent, whereas the amide it can broken down into amine through a process called the hydrolysis. And here's how it works. I'll show you how it works, the reaction mechanism and the reaction condition and what reagents required and why is that so. So let's begin. First, let's start with the amidation. So amine, so say we have an amine, which is something looks like this. And we have a carboxylic acid as well. So you can feel free to pause the video and predict the reaction mechanism by yourself. So what's going to happen is the lone pair from the nitrogen is going to attack the carboxylic acid, and the pi electron is going to move up to the oxygen. And why is that so? Is because this amine can act as a base, and this carboxylate eventually is an acid. So generally, the acid-base reaction occurs, and as a result, what will happen? As a result, a tetrahedral intermediate forms, NH R and H. Remember, we have two H here, so this is two H. I just expand it so that we can look for the movement of the electrons. And what's going to happen is proton transfer will occur. And basically, so don't forget here we have OH. So basically the electrons from oxygen is going to grab a proton from the nitrogen, and then the electron will move back to this positive nitrogen to give back the electrons to the nitrogen. This is a summarized process. So in reality, here's how it works. So we have our tetrahedral intermediate, right? So in reality, what's going to happen is a water molecule is going to grab this hydrogen from the nitrogen, and this give back the electrons to the positive nitrogen, and then we'll get something which looks like this. So this nitrogen is no longer positive, and we generate the H3O plus, right? So H3O plus, this electron from this oxygen is going to grab the hydrogen from the H3O plus that we've generated just now. So I can expand it so that we can look more clearly. So this oxygen is positive, so it will grab the proton, and this electron will goes back to oxygen to form a product, and it looks like this. OH2 with a positive charge, and here goes to our product. And a final step will occur, which is the removal of H2O. And removal of H2O basically means that this particularly is a good leaving group, so we can reform back the double bond between C and O by removing the water molecules. So therefore we'll get the amide. Particularly in this reaction, we need heat. And why we need heat is because the removal of water requires a lot of energy. So to drive the reaction forward to our product, we need heat. So to drive our reaction forward, we need heat so that the water molecules can be broken down. Alright, so now let's talk about something special about the amidation, particularly the acyl chloride. And this is a bit special because it requires different amount of base. So if you look through this reaction, what we'll get is an amide with this H is going to grab a proton, right? So HCl. So what happens here is that, as you can see, this is an acid, right? So when it is an acid, it can react with our base. So eventually let's say 1 moles of the acyl chloride react with 1 mole of the amine, and it will form 1 mole of amine and 1 mole of acid. So if this react with this, and the reaction will become inefficient, and this will decrease the product yield. So if you don't want this to happen, we don't want this acid to react with our base, to increase the percent yield of the product, we can add, first thing, is the excess or two equivalent, sometimes you'll see that, or the excess amount of the base, so that this acid will not, or so that this acid will not affect the reaction between this base and our acyl chloride. And secondly, we can add something which is the base. So other base except for the primary amine. For example, we can add pyridine. So pyridine is a good base for this reaction. So eventually it will just neutralize the hydrochloric acid and give us the space for acyl chloride and primary amine to react. And secondly, we can put the tertiary amine. So this is tertiary amine. You may wonder why tertiary amine does not react with the acyl chloride. And here's how it works. So to let this chlorine live, to become a good living group, we need hydrogen, right, to form the HCl. But however, as you can see that the tertiary amine, it does not have any hydrogen for the chloride ion to grab. So therefore, the reaction does not favors, and this reduce the probability for this reaction to happen, and that's why we can add the tertiary amine as our base to neutralize the hydrochloric acid form. Now we're going to talk about the hydrolysis of the amide to amine and the carboxylic acid or its derivatives. So particularly hydrolysis with two types. The first type is under acidic condition, while the second type is under basic condition. And generally speaking, basic condition is much more easier, the reaction mechanism, than acidic. So let's start with the more complex one, which is the acidic condition. So say we have a primary amide, and hydrolysis means that we put water under acidic condition, so we'll have the H3O plus as our acid. So what's going to happen is this oxygen, not nitrogen, yeah, because oxygen can, after oxygen grab the hydrogen from this acid, eventually we can form resonance structure, and this resonance structure will stabilize the product and therefore favor this reaction. So the electrons from the oxygen is going to grab from the acid, grab the hydrogen from the acid, and then we form a positive charge on this oxygen, right? So from here, the nitrogen, or so this structure, the oxygen or the resonance structure formed from this product will eventually just reduce the electron density from this carbon. So this carbon will be more delta positive, and that favors the nucleophilic attack by our water molecules and give back the electrons to the oxygen and form a positive oxygen again. And after that, another molecules is going to deprotonate our positive oxygen, so that we'll get a diol product, OH and OH and H2. So what's going to happen is it will react with the hydroxonium ion. So this nitrogen, now it will grabs the lone pair from this hydrogen ion and form a good living group, which is NH3 plus. So NH3 ammonia is a weak base, so it means that it's a good living group. So therefore we can form this compound, and NH3 as our ammonia. And then this oxygen is partial positive, right? So the electron from the ammonia, it will attack or grab the hydrogen and give back the electrons to the oxygen, and therefore forming our carboxylic acid as our final product, and the NH4 plus ammonium ion as our side product. Well, if you look through the overall reaction, we use acid to catalyze this reaction, and also water molecules will be added into the compound. So this is why hydrolysis. Hydrolysis means adding of water molecules. And the so if you look through the entire reaction, we only add one water molecules. You can see here at first acid is formed, and then this acid form a water molecule. Eventually these are the same because it's just the proton grabbed by the oxygen, and then these water molecules add into it, and then another water molecules come to grab the deprotonate the positive oxygen, and then forming the H3O plus hydroxonium ion, and this hydroxonium ion is going to protonate the nitrogen to form this structure. So eventually the entire reaction, we only have one water molecules added into the reaction, and the acid added is just used to drive the reaction forward. So now let's look at the basic condition. So under basic condition, the reaction is much more easier. And we have, again, say we have a primary amide. So now this time, we're going to add the base. So base means that it can straight away attack the carbon, and this electron goes up because it is a strong base, so that will form this structure, a tetrahedral intermediate form. And then from here, this is going to leave, but it's not stable. It's a very extremely unstable compound, so that this is NH2 negative. This is extremely strong base, so it will grab the hydrogen from the oxygen, therefore giving us a carboxylic ion and the ammonia. So how do we make carboxylic acid from this carboxylic ion? Very easy. We just put some acid and stir it on, and acid workout happens, carboxylic acid form. So basic is relatively easier and simple compared with the acidic condition of hydrolysis. And hydrolysis need heat as well, and that's because the amide bond is very strong, so heat is used to break the amide bond. In short, let's summarize all reactions together. If you want to form the carboxylic acid and amine from the amide, then what you have to add is hydrolysis, so water under acidic or basic condition with heat. So if you use basic condition, probably you need another acid workup. If you want to synthesis amide from amine and carboxylic acid, what you need to add is H2O and heat. That's it. So this process is known as the condensation. So it means removal of water.